Welcome to our channel. In this session, we will discuss how do we implement depth first search in artificial intelligence. First of all, what is mean by depth first search? It is an uninformed search. Means depth first search is a blind search strategy that explores the graph or tree as deeply as possible along each branch. That means starting at one vertex, it moves as deeply as possible until it reaches the leaf node. Once it reaches the leaf node, and if it is not the solution, and move to backtracking. That is DFS. And DFS is implemented by using stack data structure. Now, here we will discuss the algorithm for DFS. Here we are doing algorithms in two ways. The first one is whatever we are discussed up to now, that is open and closed. I explain the algorithm in terms of open and closed. Observe carefully. First, initialization. What happened in initialization? I am maintaining two lists, open and close. Here, open stores a list of node pairs. Understand that term? Open stores a list of node pairs. What is meant by node pair? Node pair means simply the current node and its parent node. That means here that this open, instead of storing the exact value, it stores the pair. That is the node at its parent. Now start is the root node. For the start node, there is no parent. That is the reason I written nil. Now closed, initially closed is equal to empty. Now while not null of open means if the open is not empty, that means this loop continues until the open is empty. What happened here? Within this one, take the node pair from the node pair, that is from the open. You are taking the node pair, that means the first element from the open. From this node pair, retrieve the exact value. Why? You know the meaning. Node pair means simply current node comma parent. But what we need? I need only the current node. So from this node pair, I am extracting the current node. That is the actual node that you are going to be processed. Now, whatever the node you are retrieving, if this is the goal node, simply we are returning reconstruct path of node pair comma closed. Here, what is mean by reconstruct path? Simple thing. Here, how the DFS stores the elements are stored in the form of parent and child relation. So to get the answer, simply you need to backtrack from goal to start. Yes, we are moving in this direction. If you want to get the answer, you need to backtrack from goal to start state. Then only you are getting the path from starting state to goal state. That is the reason. Reconstructing the path means backtracking. Now, okay. Otherwise, that is if the node we are selecting is not the goal node, then what you are doing? Whatever the node pair that is selected, that is moved to the closed list. Why? To prevent to prevent revisiting. Suppose if the node pair is already visited, so to avoid revisiting, that is added to the closed list. And once that is added, generate the chase. Yes or no? The same procedure we are following till now. Generates the child, that is the successors, all the possible next states of the current node, that is children. And then once the children are generated, we are applying remove scene. What happened? The children are checked in open and closed. If any node is present in open and closed, remove that one. Why? Prevention of loops. You need to remove the successors that are already present in open and closed for preventing the loops. Okay. After removing, what is this main? Attaching parent information means whatever the unvisited node is attached with its parent. Why? For path only, to get the path, what unvisited node is attached with pair. Finally, that particular node is added according to the LIFO, that is according to the stack property. The same process is repeated. Suppose if the open is empty and the goal is not found, we are returning some answer, solution is not found. Now these are the supporting algorithms. Here in the remove scene, what happened? That removes the node that are already present in the open and closed list to avoid revisiting of the already explored node. Now, occur scene. What is the meaning of occur scene? Check if a node exists. If a node exists in the list of node pairs, if it is existed or not for checking purpose. Now, make pair. What is the make pair? To make the relationship between the children and parent. Why? For path tracking. These are the supporting algorithms. In the simple terms, what happened? We are creating one node list until the goal state is found, that is node list is not empty. What you are taking? Take some element from the T and check and apply, that is explore the nodes. If it is the goal node, return true. Otherwise, move back to their children node. The same process is repeated. For example, if this is the DFS, what is the starting at node S, move to A, B, C, G. This is the path. This is the path. Clear the point? Now, the depth of the search tree means the number of levels of the search tree. Obviously, the number of nodes in the level. So, what is the time complexity? Number of nodes that are traversed. What is the space complexity? The maximum size of the open list we are maintaining. And the property completeness means, suppose if your search tree is finite, if the search tree is finite means we are generating some solution. If the search tree is infinite means there is no guarantee of solution generation. Optimality means DFS is not at all optimal, means it for reaching the solution it takes any number of steps. Anyway, you understand the basic approach of DFS. Now I will explain the DFS with this algorithm. Observe carefully. Here you are maintaining two lists, open and closed. Open and closed. The first step is initialization. So S comma nil. This is a node pair. This is a node pair and closed is empty. Closed is empty. So my search starts at node S. Initially closed list is empty. Now what is the next step? You need to expand this one. What are the childs for S? A, B and C. A, B, C. Now A comma B comma C are added to open. A comma S, B comma S, C comma S. All these are added to open. Immediately this is visited. Remove this one and placed here. S comma nil. Placed in the closed list. Here DFS follows LIFO order. The last inserted is the first out. Suppose you are placing in this order. Remember, this is not only the fixed order. If you want, you can change the order. Suppose BS, CS, AS. Why? All three are neighbors. You can make in any order. Suppose if I am placing in this order, observe this is the reverse direction. So I am selecting the last node. This is the last inserted node. Now for this node, what are the neighbors? A neighbors. B is visited, S is visited. Only thing is E. So, E comma A. E comma A. Anyway, B comma S, C comma S are available and place A comma S in the closed list. Now you got the point. Once this node pair is visited and this is not the goal node. Observe within the node pair, I am extracting the current value A. This is not the goal node. Now expand into EA and place A comma S in the closed list. Now again expand this one. What are the neighbors? D is one neighbor, G is one neighbor. For example, if I am writing in this fashion, D comma E, G comma E, and the remaining two be S, CS. Now, what about my closed? EA is added. EA, AS, S nil. Now, expand this node D comma E. Expand this node D comma E. For D, C is already visited. G is already visited. See, here G is available. C is also available. So, for C, there are no unvisited vertices. For D, there are no unvisited vertices. Directly write down the D here. D, E, A, S, S nil. Now, G comma E is at the starting. G, E, B, S and C, S. Okay. Now, this one. Extract this node pair. Now, observe this algorithm carefully. Here, what I am doing? Here, the node pair is G comma E. From this node pair, I am extracting the node G. So, goal test of G. So, G is the go node. Yes, it is true. Then I am calling the reconstruct path. So, what is the reconstruct path? Reconstruct path means you are backtrack from the goal state to starting state. So now G to E. Now from where E appear? E is appeared from E to A. A is from A to S. A is from A to S. Now you got it. This is the path reconstruction. Finally, what is the answer? S to A to E, E to G. This is the final path of the DFS algorithm. Now you got the point. The main important thing, DFS uses last in first out, that is stack principle. Always remember to update the open and close. If it is visited in the open, placed in the closed list. Okay, this is DFS. Thank you.